This is the second video lesson for the first unit in the trigonometry portion of our class. Today's lesson is about angle relationships and similar triangles. If you want to be really awesome for this first part of the notes, you will pause right now and you will go and find the following. A little piece of scrap paper. I would say little is at least 3 inches by 5 inches, but it doesn't need to be precise. Just a smallish piece of scrap paper will do. And some scissors. Okay. If you would like to go get those things right now, just pause the video and come back. If you want to be less awesome, you will just listen to me describe what happens. But sometimes doing it is more convincing and helps you to remember better. Okay, now that you're back with your scrap paper, what I'd like you to do on the scrap paper is to draw a triangle. Okay, so let's say this is my scrap paper. I'm going to draw a pretty big triangle. It takes up a lot of the paper. It doesn't need to be any particular kind of triangle. It looks to me like just eyeballing it, like I drew one that has a couple sides that are equal to each other. It does not need to be that kind of triangle. Any kind of triangle will do. Okay? Then I'd like you to take your scissors and cut out that triangle. So once you cut out the triangle, you will no longer have this extra paper around it. You will just have the triangle itself. And then once you have cut it out, if I'm hurrying you along, feel free to just pause the lesson. That's the advantage of video lessons. It can go at your pace, okay? So if I'm hurrying you, just tell me to quit for a minute and come back. So take your triangle, and now I want you to put the scissors away. So no scissors, okay? And then we're going to come over here, and what I want you to do is with your pencil, write 1, 2, and 3 on the 3 angles of the triangle. And now I want you to rip this triangle apart. And the way that I want you to rip it is so you have exactly 3 pieces, and each piece has one of the numbers. So for example, if I ripped right here, then I would be left with this piece over here that has 2 numbers on it. And I would just cut those apart, okay? And now what I'd like you to do is to take those 3 pieces, and I want you to fit them so the numbers are right next to each other. So for example, this piece here, I might slide it over here. So now it looks like this. And here's the 3, okay? And then maybe I slide this piece that has the 2 on it. I'm going to put it over here so the 2 and the 3 are looking at each other. And then I'm going to take this piece and I'm going to kind of spin it around so that its little jaggedy edge is up here. Okay, so the numbers are by each other. Now, if you think about these numbers as representing angles, which indeed they do, you have these 3 different angles. And hopefully you notice that this edge is completely straight. It's a line. It should be if you cut well, okay? If you cut accurately. What does this show us? Well, it shows us that the 3 angles in a triangle line up, right? And hopefully you understand that these 3 angles, therefore, add up to a special number. What number is it? I hope you said 180 degrees, okay? So the rule about triangles is that all 3 angles in a triangle must add up to 180. It's not that they can, it's that they have to. They always will, no matter what triangle you started with. So the 3 angles in a triangle have to add up to 180 degrees. And making that physical model shows you that that has to be the case. And so the mathematical fact that this activity demonstrated is that fact right there. I guess I kind of wrote it in the wrong spot. I guess there's a name for it we could include. Maybe that's what I meant to write there. I meant to say that this is what's called the triangle sum property. Okay, triangle, I hope that's self-evident. It's about triangles. Sum, S-U-M, means adding things together. And that's indeed what we did. We added together the 3 different angles of the triangle. All right, the next section of today's notes is about classifying triangles. You can classify triangles in 2 different ways. If you classify them by their sides, maybe a triangle has 3 sides that are equal to each other. I would show this on a picture by putting the same markings on all 3 sides, okay? that is what's called an equilateral triangle. Equilateral triangle has 3 equal sides. So maybe they're all 4 inches long or something like that. Another type of triangle classifying by their sides would be an isosceles triangle. So an isosceles triangle is one that has 2 equal sides. You might think, well, the next one must be 1 equal side, but if you think about that, that doesn't really make sense. So the last one is where no sides are equal to each other. They have 3 different lengths, and that's what's called scaling. Okay, no sides that are the same. All right, so 3 different categories if you classify the triangle according to what its sides are like. If you look at the triangle's angles, there's something that's called an acute triangle. I'll come back to what it is in just a minute. There's something that is called a right triangle. I bet you can guess what that is. And there is something that's called an obtuse triangle. Okay, now a given triangle might be, let's say, scalene and acute, or let's say isosceles and obtuse. So a triangle can be more than one of these names, but within the sides side of things, within this column, a triangle is only going to be one of those 3, and within the angles column, a given triangle will only be one of those 3, okay? An acute triangle has 3 acute angles. I hope you remember from the previous video lesson what acute means. Do you remember? Acute means the angles all are less than 90 degrees. They're between 0 and 90, so smallish numbers in terms of angles. A right triangle has to have a 90-degree angle, okay? 1 90-degree angle, okay? Must have that, and this is the symbol for right angles. Obtuse triangles have 1 obtuse angle. Remember that obtuse means more than 90 and less than 180. Notice that in this list, obtuse triangles have 1 obtuse angle, and there's 1 right angle in a right triangle. But acute, you need all 3 of them. Bing, bing, bing. All 3 of those have to be small angles or acute angles. Okay? That's heavy vocabulary. If you have a hard time learning vocabulary, perhaps use some other techniques that you know, such as flashcards. Okay? The third section is similar triangles. Okay? Similar triangles are triangles that don't have the same size, but they do have the same shape. So here's an example. I'll try to draw reasonably accurately. So let's say we had a little baby triangle, and then we had a bigger triangle that had the same size or the same proportion. It was just larger, okay? In similar triangles, what's true of the corresponding angles? This angle and this angle, for example, would be called corresponding. They are congruent. Angles are congruent, or they're equal. So if this angle was 30 degrees, so would this angle be 30 degrees, okay? In similar triangles, the corresponding sides don't have to be congruent. This is what I was just saying about the fact that they are different sizes, right? They're different sizes. The lengths can't be the same. But this side and this side will have the same ratio as this side to this side do. Okay? That was really bad English. But they're proportional. The sides are proportional, which is a way of just saying they have the same ratio. So if this length is twice as big as this length, then this length would be twice as long as this length. They would have the same relationship. Okay, so here's a sample problem. I'm going to use, I don't know why that box is still there. I'm going to use the picture that I just drew just to save some time. So let's just say that this side, I'm not going to make it twice actually, we'll make it a little different than what I was just saying. Let's say that this side was 8, and let's say that this side is 12, okay? And let's say that this side is, I don't know, I'm just making up numbers here, 6, and let's say that this side is what we want to figure out. We don't know how long that side is. If we're told that these two triangles are similar, then this is what we would do. We would say 8 is to 12, so that's 8 over 12, okay, has to be equal to, now since I did the 8 first here, I have to do the same triangle first on this side. So 8 came from the small triangle, so 6 is in the small triangle, and I'll put that over the corresponding side in the big triangle, okay? So this is what we mean by proportional. This thing right here is what is called a proportion. You recognize a proportion because you have fractions that are set equal to each other. Okay, when you have that as your starting, what you do is cross multiply. Okay, so we would take 8 times x, and we would take 12 times 6. 12 times 6 is 72. And the equal sign just falls down in the middle there. And now this is a reasonably easy question to solve. We would divide both sides by 8 using an algebra skill, and 72 divided by 8 is 9. So that tells us that missing side. You'll do problems like this in your next assignment. Thanks a lot, and feel free to go back and listen again to any part that you're confused on. Make sure your notes are very complete. This is your written notes are your proof of listening to the assignment. Thanks, and I'll see you soon.